Assalamualaikum and salam sejahtera to all the panels and also to my PSM supervisor, Encik Muhammad Fadli bin Abdul Shaib. My name is Noor Syakila Binti Mazmin and my metric number is CE180047. So I will do a final year project 2 presentation with the title Solar Panel Monitoring System based on IoT. So the introduction. The growing demands for the energy has made renewable energy resource the best alternative. So solar energy is among the most reliable source of energy. Solar panels convert to the solar energy into the electrical energy. By 2020, solar installation have increased 80% over previous year. Solar panel system monitoring is to monitor the accuracy and performance of solar panel systems. This technology can help users to monitor performance solar panel system faster and also wherever they are using the Internet of Things. The feature of this technology can contribute to its popularity among developers and users. For the problem statement, the operation and function of solar panel system can be affected as a result of various environmental factors such as impurities, radiation, and temperature. Monitor solar panels help to detect disturbance that occurs in the operation and function of solar. Power companies or communities that place solar panels networks to households need to monitor the solar panel network where the solar panels are located. So this method is very inconvenient and takes long time for user to monitor solar one by one. So the objective of this project, there are 3 objectives to achieve in this study. First, to display or monitor the voltage, current, power and temperature for solar panel using Internet of Things. Second, to calculate the accuracy of voltage and current from 2 different solar panels position. Third, to investigate the system performance from 2 different solar panels position. Scope of work. The scope of the study is focusing on following points as shown below. First, display the solar panels parameter on LCD and smartphone, which is current, voltage, and power. Second, monitoring system of solar panel quickly and anywhere using Internet of Things using Wi-Fi module ESP8266. And third, this project using Blink application to create a smartphone application. So there are 3 literature review, which is real-time data execution of solar panels using Excel, writing by A.L. Hamoumi S. Motahir, Achal L. Ghazil, A. Dorish by 2018. For the solar panels data monitoring using LabVIEW also has been written by the same person, which is for the article real-time data execution of solar panels using Excel. And for the solar energy measurement using LCD has been written by Siti Emily Muhammad Hilmi by 2018. For the real-time data execution using Excel is to measure a current, voltage and power. And for the solar panels monitoring using LabVIEW is to function to measure current, voltage and power. And for the solar energy measurement using LCD is measure temperature, light intensity, voltage and power. And then they are using for the real-time data execution of solar panels using Excel, they are using current sensor NE169 and voltage sensor F03106. And then the output we display in Excel. And for the solar panel monitoring using LabVIEW, they are using current sensor INA169, voltage sensor F03106, and the output we display on the LabVIEW. And for the solar energy measurement using LCD, the current sensor module, they are using the current sensor module, voltage divider, LDR sensor, temperature sensor, and the output we display at the LCD. So in this project, solar panel monitoring system based on IoT, we are going to measure voltage, current, power, and temperature. So in this project, we are using a current sensor ACS712, voltage sensor F013106, temperature sensor DHT11. This and then the output we display at the LCD and the smartphone by using Blink IoT application. So for the methodology of this project, we are going to use two solar panels and then the solar panels as an input, and then we are using a voltage sensor to detect a voltage from the solar panels and a current sensor to detect the current from the solar panels, and then the sensor will send the data to the controller. The controller will send the data to the LCD, and then the controller will send the output to the LCD and ESP8266 Wi-Fi module, and then the Wi-Fi module will send the data to the Blink application, which is Blink IoT, and then the result will display on the smartphone. So this is the flowchart of this project. So first we are going to collect data from the solar panel 1 and solar panels 2, and also the temperature sensor. And then solar panel, we go to the voltage sensor. Voltage sensor will detect the voltage. If yes, it will proceed to the current sensor. If the current sensor is detected, they will calculate the power. And then after finish calculate the power, the result, the output will display on LCD, the voltage, current, and power and temperature will display on the LCD, and also we display and then we'll send the data to the ESP8266 and it will display on the smartphone. And then here is the result. As you guys can see, display the reading of voltage, current, power, and temperature on LCD and Blink IoT in the smartphone. So as we can see here, the voltage for the solar panel 1 is 4.09 volt and the temperature is 0.64, and here also got 0.64, and the power is 2.61, and the temperature is 29.8 Celsius. And also for the voltage sensor 2, also 4.33 volt, and the current is 0.33 milliampere, and the power is 1.41 milliwatt, and the temperature is 29.8 Celsius. So testing data for the voltage sensor. We are going to test the voltage sensor with load and without load. So this is a without load. The minimum error is 13.27% and the maximum error is 41.52%. And for the solar panel ones, is the minimum error is 0.4% and 23.58%. So as we can see here, the solar panels 2 more accurate from the graph we seen. The solar panel 2 more accurate than solar panel 1. So let's proceed to the testing data for voltage sensor with load. So as you can see here, the minimum rate error is 19.89% and the maximum rate error is 33.89%. And for the solar panel 2, the minimum rate error is 6.47% and the maximum rate error is 40%. So based on the graph, we can see the solar panels 2 more accurate than solar panel 1, since the few results are almost same to the measure. So next, for the testing data for a current sensor, as you can see here, the minimum error is 0.01 milliampere and the maximum error is 0.62 milliampere. And for the solar panels 2, the minimum error is 0.01 milliampere and the maximum error is 0.73 milliampere. But From the graph we have seen, a few results from the LCD are not accurate with the smartphone since our LCD has been displayed a negative value for the current. But for our smartphone, we already set the current need to large than zero. So that's why the LCD and the smartphone are not accurate. So as we can see, based on these two result, the graph for the solar panel 1 show more stable than solar panels 2. So for the data, the testing data for the current sensor with load, as we can see here, minimum error is 0.08 milliampere and maximum error is 0.54 milliampere. And for the solar panel 2, the minimum error is 0.01 milliampere and the maximum is 0.54 milliampere. So, sorry, I have made some mistake. The error is 0.7. The error is 0.54. Yeah. The error is 0.54. So as you can see here, the result, based on the result, the most the solar panels for the solar panels 2 current is more accurate than solar panels 1. And also we can see both solar panel doesn't have a stable current display on the LCD and smartphone. So for the testing accuracy for the solar panel 1 and solar panels 2, we can see here the orange line is for the solar panel 2 and the blue line is for the solar panel 1. So as we can see, the voltage for the solar panel 1 is higher than, for the solar panel 2 is higher than for solar panels 1. But so we can see the performance for the solar panels 2 is better than solar panel 1. It is because maybe it is because there are causes of the shadow, which is the solar panel 1 are not accept the same value of light as solar panels do. And then the conclusion is the project has a useful design and reward system for them, especially solar panel installation or production companies. It can help them to detect which solar panels has been damaged or have disturbance amongst many other solar panels. To produce and ensure the performance of solar panels works well. This is because current, voltage, irradiation, and temperature can affect solar efficiency. Solar panels monitoring system in real time is to monitoring system in PV power plant in any time and anywhere. It is very important and urgent in some cases for analysis, problem solving, and in issue discussion making. So for the recommendation of this project, the reading produced by the current sensor are less stable and inaccurate as there are some readings measured and displayed on the LCD and the blink application is inaccurate compared to the actual reading values from the multimeter. Further studies require the use of more stable sensors and the use of accurate sensors to obtain accurate voltage and current readings. So here is the Gantt chart for the PSM2. So I will proceed this presentation for the project demonstration. So that's all from me. Thank you.